Okay, let us discuss problem number 1.261. So this says a plank of mass m1 with uniform sphere of mass m2 placed on it rests on a horizontal smooth plane. So we have a horizontal smooth plane. So this plane is smooth, mu is 0. Over this plane we have a plank. So a plank is kept over this plane. And the mass of the plank is m1. Over this there is a solid sphere, uniform solid sphere of mass m2 that is kept. So over this plank mass is m2 and this is solid sphere. So let me write I is 2 by 5 m2. If the radius if this sphere is a small r, so this is r square. So this is I of solid sphere. Now next part says a constant horizontal force F is applied to the plank. So somebody apply a force F to the plank. Constant. So F is not variable, this is constant. So F is basically constant force. So we are applying a constant horizontal force. This is again horizontal. It's not inclined. With what acceleration will the plank and the center of a sphere move, provided there is no sliding between the plank and the sphere? So question says there is no sliding between a sphere and this plank. So no sliding. Of course there will be sliding because in this friction is 0. So no sliding between plank and a sphere. So you have been given no sliding. That is the case of pure rolling. No sliding between a sphere and plank. Now this means this is a case of pure rolling. Now other important point is this, and the friction force that we lack, this is a case of pure rolling. So let us try to solve this problem. So since there is no sliding, so the friction force that will act here is basically static in nature, because this is the case of pure rolling. So over this plank, this sphere is doing pure rolling. So the friction that will act is static in nature. So friction force is static, and that's why friction coefficient is not given. So friction will be static in nature. Let us say this plank is moving with acceleration a1 and this is moving with acceleration a2 with respect to the plank. You see, this sphere is doing pure rolling but with respect to this plank. So this is in the pure rolling with respect to plank. So I can assume acceleration of this sphere is a2 but with respect to the plank. So what we are saying, acceleration of this is a2 and acceleration of this is a1. a2 is given with respect to plank. So let me see here. So this is my m2. Acceleration of this is a2 but this is with respect to plank. Now let's say what the forces that is acting on the plank, F, and let us say acceleration of this is a1 and this is with respect to ground. So a1 is with respect to ground. Now let us try to see friction forces. So if this goes this side, I have said the acceleration of this is a1 this side. So, and this is going this side with acceleration a2. Let us say what should be the friction force? So let us first decide the friction force. On this surface, deciding the friction force is easy because this has a tendency to go in this direction. So friction force on this should act in the opposite direction. So this point will have a tendency to go forward. So friction force will act backward. That is opposite of slipping tendency. So this point has a tendency to slip this side. So friction force this side. Newton's third law says on this friction force will act in this direction. Now don't worry about the direction of friction force. We'll solve the equation. If this comes out to be positive, then the direction is correct. If this comes out to be negative, then direction is incorrect. So I have to reverse in that case. So let us don't worry about the direction. Even if you have taken this side friction and if you have taken this side friction, that will also give you the same answer, only with a minus sign of friction. Now this Planck has an acceleration of a2 with respect to Planck. So this object has acceleration a2 with respect to Planck. Now the Planck itself is a non-inertial frame. It is moving with acceleration a1. So to write Newton's second law for this object, I have to apply a pseudo force, and pseudo force will be opposite to the acceleration vector. So acceleration in this case is a1 in this side. So you will have a pseudo force m2 into a1, and that is opposite. So this is my pseudo. Now things are very easy. Simply I have to write down the equation. So this is mass m1. So let us say write equation for this. So I can write F minus F is equals to m1 a1. So this is my equation 1. For this, force F minus m2 a1, this is equals to mass into acceleration. So mass is m2 and acceleration is a2. So this is equation 2. Now equation 3 I can write for torque. So this is a moving with, so this is going this side with acceleration a2. So this has to move in this direction also. Are you getting? So let us say this is moving with angular acceleration alpha, and now this is a pure rolling with respect to this. So alpha is basically equals to a2 by r, because this is a case of pure rolling. Are you getting or not? So let us write equation for torque. So F is equals to, so torque is F into R. So this is opposite to the rotation, so minus F into R is equals to, I is 2 by 5 mr square and mass is m2 r square into alpha. Alpha is nothing but a2 by r. So from here I can write F is minus F is 2 by 5 m2 a2. Are you getting or not? So this is equation number 3. Now I can solve for equation number 1, 2, 3 for a2 or a1. So what we have to find out? We have to find out a1. So let us say, let me see what the question asks. So find out what will be the acceleration of Planck as well as, so both a1, a2. So let us say plug this value of a2 in terms of F here. So from equation 2 I will have, so let us plug the value of a2. m2 a2 is nothing but minus 5 by 2f. So this is f minus m2 a1, and m2 a2 is nothing but minus 5f by 2. Are you getting or not? So I can have, so this is f plus f. So f plus 5f by 2, this is equals to m2 a1. So we will have 5 plus 2, 7f by 2. This is equals to m2 a1. I think you are able to see this one, m2 a1. Now if you use the equation 1, so this equation, so you see you have written already, you can check your copy. Capital F minus F, this is equals to m1 a1. So plug the value of F. So capital F minus F, we have equation capital F minus F, this is equals to m1 a1. So capital F minus small f, this is equals to m1 a1. Now I can plug the value of F. F is nothing but 2 by 7 m2 a1. So this is F minus 2 by 7 m2 a1, and this is equals to m1 a1. Now if I take this side, so I will have F is equals to m1 plus 2 by 7 m2 into a1. Are you getting? So if I solve for F a1, I will have 7f, this divided by 7m1 plus 2m2. So this is the acceleration we will have. So this is the acceleration of Planck. Similarly, you can solve for A2. Now you see A2 is what? So we have already said. So I have equation for A2. So you can solve yourself. So this you do yourself. So do yourself. So let us find A2 yourself. Now let me find friction force. So friction force F minus F is equals to M1A1. So let us try to find F minus F. This is equals to M1A1. I will wait for some time so that you can find A2. And please check with your colleague whether all of you are getting same answer or not. Let us wait for 1 minute. Okay, let us solve for friction force. So I have friction force. Okay, this equation I can directly apply. So friction force is 7F by 2 is equals to M2A1. Are you getting? So this friction force is nothing but 2 by 7 M2A1. So friction force is equals to 2 by 7 M2A1. Are you getting? So you see this equation. So friction force is equals to 2 by 7 M2A1. So this is 2 by 7 M2 and A1 is this 7F divided by 7 M1 plus 2 M2. Now you see 7 goes, so you will have 2F M2 divided by 7 M1 plus 2 M2. Why I am solving this for friction force? Question does not ask. This is doing because now you see this term is a positive. So this means the direction of friction force that I have assumed is basically correct. Are you getting or not? So you can always check it out whether the friction force, direction of friction force is coming out to be positive or not. If it's coming out to be positive, this means the direction which we have assumed is basically correct. Now another important point, somebody can ask, you have assumed acceleration A2 in this side, why you have assumed alpha in this direction? This I have done because this is a case of pure rolling. So you see with respect to this is a case of pure rolling. So this is alpha is also with respect. So if this has acceleration A2, this point also has acceleration A2. Are you getting? Now this is basically in rest with respect to this. This point is rest with respect to pure rolling. So this is a rest with respect to this. So if I take alpha this side and then I will have alpha times r, that is alpha times r, this is equals to 0 because you have some velocity, some acceleration this side, some acceleration this side. So A2 is equals to alpha r is possible only if you take alpha this direction. If you take alpha in this direction, you will never have this acceleration 0. You will have a point, contact point, slipping point, that is a point of contact you will have A2 plus alpha. So the question says this is a case of pure rolling, and that's why you have to take alpha in this direction, because I should to have one acceleration of the point of contact in this direction and one acceleration in this direction. So this is another important point we have in this question. In this question, one important point we have, that is this is a pure rolling with respect to the Planck. So this is not a pure rolling with respect to the ground, pure rolling with respect to the Planck. So what we will do is we will take help of pseudo force. So we will take acceleration of this sphere with respect to the Planck, and then we will apply this concept of pseudo force. Now let us discuss the next problem.